All right. Good afternoon, Jamie.
Evening, sir.
All right. Yes, good evening. Congratulations. I see that you placed second in, what was it, second or third in the Caribbean in biology?
In bio, it was fourth and eighth in chemistry.
Congratulations, man. Excellent job. Excellent. Well done. I know that you're very hardworking, but you can see that the results is there. So congratulations. All right.
Thank you, sir.
Yeah, and make sure that when you go to the regional awards and the national awards, you know, make sure you're fresh, put on your best looking suit, because that's a picture to keep for the ages. All right.
Yes, sir.
All right, great. So what I'm saying is, I see that your place, say no, say intimate, we're going for something too, don't it?
Yes, sir.
All right, we're going for something too as well for intimate, definitely. Now I was looking at your intimate IA and I'm really happy. I'm really happy that you got the data as well for the 30 students. All right.
Yeah.
So what I'm gonna ask, can you hear me?
Yeah, I can hear you.
Okay. Yes, I can. Yeah, go ahead now. You were saying something.
I said it was fun. We took 2 sessions and just did all of it.
2 sessions and got all the results, right?
Yes, sir.
Okay, excellent. All right, now that you have the results, what I want you to do is to get the ratio now. All right, check if the ratio is 1. Well, you know how to do the ratio, the finger to the span to height. When you do it now, you create your next column. Get all the ratios. You see those results that you're gonna get, and you're gonna place it in another table, right? I'm just writing some rough numbers here. All right, this is not actual. I'm just making a guesstimate. 176 over 169, maybe 1.1. Maybe 1.1. Maybe this one is 1.05. You get what I'm saying? But I want you to get the results now. And what you're going to do after you get the results is, now that we learned stem and leaf and box plot, I want you to create a stem and leaf and box plot, right? And I'm going to show you how you do it in Excel after we finish today. All right, Jamie?
Sir, my teacher also said to make a scatter plot.
Yeah, we're going to remember, you know, look at this. As we go along the way, we're going to put everything in the SP. I want everything to be there. I want when your teacher sees, you say, whoa, she's going to say by, bar. She's going to say all these information. But as we cover each topic, I'm going to tell you how you're going to put it into the SBA. All right?
All right.
Yeah. So remember last week we only did box plot and stem and leaf. So these are what you're going to start with now, don't it?
Yes, sir.
Yeah, don't worry about the scatter plot yet, all right? We're more going to look at scatter plot when we get into regression analysis. Well, you don't do regression analysis, you just do linear regression in integrated math. All right, it's really fun. So we'll get more to regression analysis, then we're going to look at scatter plot. I like to teach the two of them hand in hand because they're hand in hand topics. So for today, there was a question that I wanted you to do that you didn't get to do last time. This was when they give you the box plot. So sometimes, Jamie, they give you the box plot and then ask you to answer question, or they give you the stem and leaf and ask you to answer question. So I don't know if you have the document open, but here's the box plot. So I want you to write down the necessary data that this box plot is giving you. Remind me of the 5 data the box plot gave.
The box plot gives you the skewing of the median in the range.
The 5 informations that it gives you, the 5. We don't talk about skewness yet. We're going to talk about skewness today. But I told you 5 information the box plot give you.
The highest and lowest part,
Highest, lowest, very good.
the median,
Median, good.
the
Line right here. And what
third
else?
quartile,
The what?
the third quartile, and first
Yes,
quartile.
the upper quartile. Yeah, very good. And the lower quartile. All right, so Jamie, can you open this document? You don't have to share it, but open it. And I want you to answer the following question from these two here. From the document that was sent last week with Brian and Lewis, I want you to share your screen now and use the box plot to answer these questions. All right, answer the first part, the second part, and the third part. First, second, and third.
Or
All right, you can share your screen when you're ready. Okay, great. So work out the interquartile range for both Brian and Lewis.
is there any type of scale? It's kind of hard to tell where the numbers
Just
are.
zoom, can you zoom in? Just zoom in and look at it. No, they won't penalize you in an exam. Like if, let's say the number is 42 and you put 43, they won't penalize you. You just have to look close and make the best approximation. All right, so you said the highest is 97, all right. All right, good. So interquartile range now. All right, good. Interquartile is good. Good. All right, state one advantage and one disadvantage of the box plot. All right, so we're allowed to see the distribution. Very good. All right, it allows, you don't have to say you can say us, because you're doing it as well. Yeah, yeah, nice. A disadvantage. All right, very good. We don't know what is the mean exactly, right? We don't know what's the mean and the mode, right? So we don't really understand what's happening in terms of the other measures of central tendency. Very good, Jamie. Now, Jamie, I left out something out of the notes. All right. So my apologies. We're gonna have to write here. We're gonna write. Maybe I'll share this document. Well, yeah, I'll just share this document. So I'm gonna have to write. I put a lot of time putting it together, but then I realized I left out standard deviation. All right. So we're gonna just write standard deviation. Okay. So standard deviation. Now, what is standard deviation, Jamie? Standard deviation is pretty much a measure of spread. It is how much a variable, how much it differ from the mean. Literally, it's how much on average do each measurement differ from the mean. That's what we're looking to see. Standard deviation, how much each measurement is going to differ from the mean. All right, that's all standard deviation is. Now, when we do the computation, you'll realize why it is that. So this is the formula we're going to be using for standard deviation. There are two formulas. All right, standard deviation. Now, Jamie, there's two formulas we're going to use. We're going to use one, a different formula for group data, and a different formula for ungrouped data. So let's start with ungrouped data. Ungrouped data. For ungrouped data is like when you get numbers like 15, 20, 23, 17, and 11. Don't it, Jamie? That's ungrouped data, right?
Yes, sir.
And group data is when you get it in the table with whole heap of things, don't it?
Yes,
Cool, cool, cool. So we know what's happening. I'm happy. Good. So now with ungrouped data, this is the formula we're going to use. Sorry. The standard deviation square. So S square. Now, Jamie, you say S square. This S square, we generally call this sigma. This is also known as the variance. S square, the standard deviation square is known as the variance. So standard deviation, when you square it, the result we generally call it variance. Now, I haven't seen any past paper ask anything really about variance. It generally asks you to calculate standard deviation, but the syllabus wants you to know what is variance. So always remember, variance is just the standard deviation square. So the standard deviation is given by the sum of all the xi values minus bar x square divided by n. All right. Now, sometime it might say they divide by n minus 1 if the sample size is large, but generally we divide by n. So if you type it in Google standard deviation, you're going to see n minus 1. But that's generally when it's large data set. For us, in Inte math, generally the data set won't be more than 30 variables, so we use n. All right. I'm just clarifying if you go pursue math later on, right? Anything you're doing with math, you say n minus 1, you can't say I didn't tell you, say they use n minus 1 when it's a large data set. All right. So in other words, the standard deviation would work out to just be the square root of the sum of xi minus bar x all square divided by n. That's the formula for standard deviation. All right. So let's look at an example now. We're going to do an example, and then I'm going to give you a data set to find this. No, I want to give you one. There are questions that you can complete the question. So let's do one together now. So let's say we're looking at scores in Inte math at Bel Air. All right, we're looking at scores in Inte math at Bel Air. So we're looking at the scores, and this is for 10 students, 10 students. All right, so maybe a person get 23, somebody gets 77, somebody gets 61, somebody gets 59, somebody gets 60, somebody gets 60. But Jamie, the top man, get 97, somebody get 81, somebody get 29, and then somebody begging the teacher for an extra mark, get 49, and the teacher said, no, can't find the extra mark. So these are the 10 grades. All right, so when we're finding the standard deviation, the first thing we do, Jamie, is find the mean. So step one is to find the mean. So find the mean. So in this case, we'll find the mean, and we know mean is bar x. We'll add up all of this, 23 plus 77 plus 61 plus 59 plus 60 plus 60 plus 97 plus 81 plus 29 plus 49. I will divide it by how many scores it is? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So we'll put that in our calculator. What is that? Let me take out my
59.6.
59.6?
Yeah.
59.6. All right. So that would be the average. My gosh, that's a low average. Now, 59.6 is the average for the test, but no problem. This is step two. Step two, I prefer when we do it this way. I like to do it in a table. Step two, you're going to prepare the table. This is the table we're going to prepare, Jamie. So we're going to have a XI column. I like to do it in a table. Many teachers might not do it in a table, but for me, I think it's a little easier to put it in a table. These are our XI columns. XI represent the scores. In this case, the scores were 23, 77, 59, 60, 97, 60, 81, 29, and 49. Why is it doing that? Why is it carrying over? Nice. Why did it do that? Why is it? All right, I think something is wrong with my PowerPoint. I don't know why it's doing that. Because look at that. It's like, it's as if, let me see. It's annoying me. That's annoying me. Because it's not there. There it is, it's not there. What's the issue? All right, so 60, 81, 29, and 49. So sorry about the delay. That was just annoying me. Now, the next thing you're going to then work out, Jamie, is you're going to work out xi minus bar x squared, right? So these set of values that you're going to...
That's 9 values. I think there's one more.
It's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Thank you. Which value was missing? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which value? 49, 29, 81. Which value?
Yeah, 61.
Oh, 61. Thank you. So put in the 61. Let us put the 61 here. All right. Then the next thing you're going to work out in the table is xi minus bar x square. So remember we had to work out bar x. So bar x we said was 59.6. This was our bar x. All right, so you're going to work out your bar x, 59.6, subtract it from 23 and then square it. So it is 23 minus 59.6 square. You don't need to show all of that working. So just put that in our calculator. 23 minus 59.6 all square. What is that?
It's 1339.56.
1399 point?
No, 39.
139.56?
1339.56.
1339.56?
Yes, sir.
Okay, great. All right, work out 77 minus 59.6 all square.
About 302.76.
All right, 302.76. 302.76. All right, let me help out so it move a little faster. 59 minus 59.6 squared, that's 0.36.
So
60 minus 59.6 square, that's 0.16. 97 minus 59, 97 minus 59.6 square, that's 1398.76. 60 minus, oh, that was 0.16 we said. 81 minus 59.6 square, that's 457.96. 29 minus 59.6, that is negative 30.6. Then you square it, that's 936.36. 49 minus 59.6. Then we square it, that's 112.36. Then 61 minus 59.6. Then we square it, that's 1.96. So the next thing we're going to do now, Jamie, is just write down the sum of all of it. The sum of xi minus bar x square. So adding up all of these now. Let me change the color. Put yellow. We add all of these. Add. So you add all of them now. And 1339.56 plus 302.76 plus 0.36 plus 0.16 plus 1398.76 plus 0.16 plus 457.96 plus 936.36 plus 112.36 plus 1.96. We add that up. Did you get the same thing as what I got here? I got 4,550.4. That's what you got?
I wasn't adding it.
Okay, no problem. All right, but this is what we get when we add it up. All right. Then now you can actually use the formula. So now step 3, use the formula to say, remember that S, the standard deviation, is the square root of the sum of xi minus bar x all square divided by n. So this is just now the square root of, you already found out the sum of all of this, which is 4,550.4 divided by n, which is 10. You put that in a calculator, 4,550.4 divided by 10. That's 455.04. And then when you square root it, you get about 21 point something, 21.33. So what this means, Jamie, in other words, it means that on average, this is what standard deviation means now. In the definition of standard deviation, it is saying on average, each score differ from the mean by 21.33. So on average, so you see like how you can find the mean? Standard deviation is like the mean difference. You get what I'm saying, Jamie? So look at this. The mean was 59, right? This person get 23. So the person score differed from the mean by 30 something, don't it?
Yes, sir.
And then this person score differed by 20 something. This person score barely differ, 0 point something, 1 point something. This person score barely differ, 0 point something. But it's just saying on average, the scores each deviate from the mean by 21.33. All right, that's what standard deviation means. Cool with that, Jamie?
Yes, sir.
Now you're probably wondering why they use this formula then if it's the average of what it differ by. Why use that when we can just say 59 minus 23, you get a number, then you add it with this, then you subtract, add it with this, then, right, Jamie? You're wondering why this square and square root thing? Why you think was square and square root? Tell me why you think. Yeah, tell me why you think was square and square root. Just think about it. Tell me why you think was square root.
I would say to get positive or negative accounted for.
Very good, Jamie. Sharp. Now I'm so happy you said it. So, Jamie, I teach applied, and I can tell you that when I ask the persons, the gentlemen about applied math, why do we do this? So many of them didn't tell me that. You have to account for plus or minus, because look at this. 23 minus 59.6 and negative 36. If we were to ever go stay so, negative 36 plus this value, 22, plus some other negative values, it gonna give us some 0 point something, don't it?
Yes, sir.
Yeah, it now gonna give you the true deviation from the mean. So to get the true deviation from the mean, we square it, but then for ignore, so we square it, we square root it back. Does that make sense?
Yes, sir.
So by squaring it and square rooting it back, we ignore all of that right there. So take down this formula, Jamie, and now I'm going to give you a question. Well, I'm not going to give you a question. You're going to go back to the worksheet that you were doing last week. You have it open already. So for the two scores now, I remember, let me go to the document here. I remember you were doing this and I said, leave out this part with Rustan and Shimran to work out the standard deviation of both players. Each standard deviation is usually about 4 marks. 4 and 4 is 8. But it's a 10, but no problem. 2 additional marks, but usually that would just be 8 marks. 4 marks to the standard deviation. So do this one. I want you to go back. I will copy Shimran and Rastan's scores for you so you can work out the standard deviation. The share screen and then I copy these scores for you. All right, so the first 10 is Rastan and the next 10 is Shimron. Work out the standard deviation. Oh, I thought you don't remember the mean that you calculated from last week because I was trying to remember what it was again, but I can't remember.
I can't remember.
Yeah. Yeah, 43.7. Couldn't remember that. Remember, Shimron was 30 something. You're not gonna need more space. You might get some
Oh, yeah.
decimal. Yeah, you might get some decimals. You might want a little more space. Oh, by the way, Jamie, so when we finish module one, I'm going to give you a module one test. All right. And then I mark it. And depending on how well it is, then we determine if we go through it. All right. For regular Thursday stream. All right.
All right.
Yeah. We have two more topics in module one. And the reason why I want to give you a quiz, as I say that we have potential to be in the top 10. So we're definitely going for it. And each module when we finish, we get a test. We're going for the 20 out of 20. We're going to get the 20 out of 20. Paper one, them already put down. Don't worry about paper one yet. So we're going to make the top 10. All right, Jamie?
All right, sir.
All right, great. All right, good. Add them up now. All right, so the standard deviation is 22.52. Good.
We have to calculate this.
Yeah. 26. Good point. Yeah. Well done, Jamie. Well done. Well done. Well done. All right. Now, there's something important that we need to know about standard deviation. So, well done. All right. Are you seeing the PowerPoint?
So,
Okay, great. All right. Key thing to take away from standard deviation. All right. So, Jamie, these are known as measures of spread. Measures of spread. Measures of spread. These are used to determine the variability, determine or compare variability. All right. And measures of spread include range, interquartile range, standard deviation, and variance. All right. These are the 4 data that we're going to use to compare the spread of a data. All right. How much data is spreading. And then now the measures of central tendency. These are the measures of central tendency. Mean, mode, and median. So at the end of the day, Jamie, what they're going to do a lot of the times is they're going to ask you to describe like which data set is better. All right. Anytime you're comparing 2 data sets, you use the 2 information them from the spread and from the tendency to determine which is better. So I don't know if you remember this question. It had actually asked you something like, not right here. It had actually asked something like, based on your computations from 1 to 5, who would you select to represent the West Indies to bat at number 4 in their first World Cup match against England? So in other words, you might go and say, well, Roston have a better average, so I select Roston, right? That's a valid reason. They say give reasons for your answer. Somebody else might say, I select Roston because his standard deviation is lower, suggesting that he's more consistent. But then somebody else might suggest Hetmeyer because the median is better. You get what I'm saying, Jamie?
yes, sir.
So these now, you see, when you're doing an SBA, you have to look at overall all the numbers and then match up to see who would be better. But of course, in an exam, you can pick which reason you want to be an answer. You can choose because it asks based on your computation, who would you choose? But when you do a SBA now, you're going to have to look at overall because you can't be biased now, you can't be biased towards just the mean, right? Because look at this. I'm going to show you some data set right here. So look at this. Let's say I give you 2 students. 2 students. Look at this. Student A get grades 70, 40, 100, and 80, and 60. And student B get this. 65, 75, 70, 70, 77, 65, 65, 75, 65, 75, 70, 77, and let's say he gets a 63, right? And a question might ask which of these students is doing better. Now, if you look at it, Jamie, look at it. Student A, if you look at the mean for student A, the mean for student A, that's 70 plus 40 plus 100 plus 80 plus 60, and you divide that by 6. That's going to be 110, 210, 290, 350. Wait, I divide by 5, right? 350 over 5. That's an average of 70, don't it, Jamie?
Yes, sir.
And the mean of student B would be 65 plus 75 plus 70 plus 77 plus 63. When I add that up, this is 65 and 70, that's 75, that's 150, 220, adding up to the same 350. So look at that, Jamie. Notice that the two of them have an average of what? 70, don't it?
Yes, sir.
But notice if you were to work out the standard deviation, I guarantee the standard deviation for student B would be lower because him barely deviate from the mean. Him very consistent because look at this, his range, the highest him get is 77 and the lowest him get is 63. His range is 14. I guarantee his standard deviation is 2 or 3, maybe even 5 maximum. But look how much student A deviates. Sometime him grade 30 below the average, 30 above him average, 10 above him average, 20 below him average. So him all over the place, don't it?
Yes, sir.
So even though him have a good average, you notice him grades all over the place. So the bigger the standard deviation, so the larger the standard deviation, the less consistent are the results. The less consistent are the results. So generally we want to have data sets that are going to be more consistent. All right. So if we're going to make a selection on something, we generally want to make the selection with something with a lower standard deviation. So generally when the mean and the median are close, we then tend to look at the spread to see which one is more consistent. All right. So all of these, you're going to compute your SBA now to see what's the standard deviation, what's the norm, right? How much is the finger span deviating, finger span to height ratio deviating from person to person. We look at the standard deviation, and we also compute all the measures of central tendency. So you can compute all the ratios to find the average ratio, the mode ratio, the median ratio. All right. So I want all of these, I want you to do it for next class. Next week, Wednesday, I want you to send it to me by email. But we're going to, closer to the end of class, we're going to mention that. All right. So yeah, for your data set that you have so far, I want you to, after you work out the ratios, I want you to work out the mean ratio, mode ratio, median ratio. Then you're going to work out the range, interquartile, standard deviation. You don't have to work out variance because standard deviation is the main thing. These are the main three. All right, we're going to work those out because these are what you're going to use to help in your discussion. All right. And as I said, each week we'll cover a topic in statistics, we'll build on. So later on, so now we're looking at these, but when we get to regression, that's where you're really going to look at the scatter plot and then make the real big comparison. That's the best topic in statistics, the linear regression. The last one we're going to do, the scatter plot. All right, so now that we do this now, and I showed you that standard deviation, the less the standard deviation is, the better it is. So now we're good. All right, so what I want you to do, Jamie, is when you're going back through this worksheet, I want you to look and ask yourself, based on all of the answers that you got, when you're going back through the recordings, you can say, oh, which player would I select? All right, you comment. All right. All right, Jamie?
Answer. Yeah.
All right, now let's look at for group data for this now. So sometimes I might get a question like this, which is for group data. All right, even though this is not a group data question, but let's look at the group data now for standard deviation. So for group data, Jamie, this is the formula we're going to use. Let me insert some new slides. Might need about 5. Your teacher might give you the formula slightly different from me because they might be going with the formula from the formula sheet, but I don't like to use that. This is the formula we're going to use for group data. All right. So for group data, Jamie, let me draw a table to show you generally what it's going to look like. So generally, they're going to give you scores. They're going to give you scores like these represent your XIs, right? We don't know what that could be. Maybe shoe size, right? Maybe the shoe size, and then this is frequency, right? Just information in the table, right? Table information. With group data, this is the formula you're going to use. Standard deviation is equal to the square root of, it's equal to the sum of the frequency times x, frequency times x square minus the sum of the frequency times x all square divided by n, all divided by n. Now, a lot of teachers might simplify this formula by writing the numerator as one fraction, so then they can cancel the n over n. But I don't like cancel the n over n. I like to use it this way. All right, so you can always cancel the n over n. So you may see teachers write it this way. Let me write it in black. All right, so this would be the sum of fx squared minus the sum, and it's multiplied by n. So n times it over n, all divided by n. And then all I did was write the numerator as one fraction, right, Jamie? Because this is over 1, right?
Yes, sir.
And so to write it as one fraction, I just find the LCM. To find the LCM, it would be 1 into n goes n times, so n times this. That's all I do. Then, of course, you know, when you get to this stage, you can simplify, because with fractions, you have, if you have a fraction a over b and you're dividing it by c, it's the same as a over b multiplied by 1 over c, right?
Yes, sir.
So in other words, this would then become this n right here. We'll multiply it by this n, and you end up get an n squared. And then the n from this n cancel. And that's how they reduce it. But I don't like the reduced formula that you're going to see on the formula sheet. So I'm going to take it off. I don't even want to store it in my memory. As I said, it's the same formula. It's just that they simplify it to write it as one fraction. I prefer do it this way. That's just my preference, all right? So this is the formula that we're going to use. So now we're going to look at a typical example, Jamie. So group data is used when the data set is extremely large. So for example, look at this, Jamie. Let's say we're talking about shoe sizes. We're talking about shoe sizes for students in your class, right? And maybe of a class of 30 students, let's say there's 30 students, right? These are the shoe sizes, size 7, size 7.5, size 8, size 8.5, size 9, size 9.5, and size 10. These are the shoe size, right, Jamie? Nobody foot bigger than 10 for now. For now, is that okay?
Yes, sir.
Maybe after 30 students in the class, let's say 2 persons wear size 7, 3 persons wear 7.5, 5 people wear 8, 7 wear 8.5, 2 wear 9, 4 wear 9.5. Let me see. 5, 10, 17, 19, 23. No, let me put on a little bit more then. Let's say more people wear 9. So 8 people wear 9. 8 people wear 9. So this is 2, 5, 10, 17, 25, 29, and 1 person wear size 10. So that's what we have. All right, cool with this?
Yes, sir.
So this is the sum of 30. Now, Jamie, I see what some persons do. What some persons like to do is write out the entire 30 data set. Because if 2 persons wear 7, You can write 7 then 7, don't it?
Yes, sir.
And then 3 people were 7.5, so you write 7.5 3 times, right?
Yes, sir.
And you'd write 8 how much time?
5.
Very good. Now, Jamie, I don't know why some persons like to do it this way. Some persons like to actually write out all of it. So instead, they can just use the regular formula. Like I've literally seen persons only know this formula, so they write out the entire table. All when the table have 100 data points. No, we don't want to do that. This is where we need to use the table formula and just go ahead and do the calculation. So the first thing, Jamie, is we need fx squared. So look, this is your x column and this is your f column. All right. So you're going to just add on the side fx squared. Fx squared. That's all you're going to add on. So fx squared is going to be, we work out 2 times 7 squared. So we work out 2 times 7 squared. That's 98. Then we work out 3 times 7.5 squared. That's 168.75. Now work out 5 times 8 squared. That's 320. 7 times 8.5 squared. That's 505.75. Then 8 times 9 squared. That's 648. Then 4 times 9.5 squared. That's 361. And then 1 times 10 squared, that's 100. All right, cool. So then what we do, Jamie, is add up all of this. We'll find the sum. Add up all of it. We'll add up all of it. We get 98 plus 168.75 plus 320 plus 505.75 plus 648 plus 361 plus 100. When we add it up, we get 2201.5. What you then do next, Jamie, is you're going to work out a table that is going to be f times x. That one is not too bad. F times x, we work out f times x, that is 2 times 7, 14, 3 times 7.5, that's 22.5. Then we have 5 times 8 is 40. 7 times 8.5, that's 59.5. Then we work out 8 times 9, 72. Then we work out 4 times 9.5, which is 38. Then 1 times 10, which is 10. You then add up all of this. 14 plus 22.5 plus 40 plus 59.5 plus 72 plus 38 plus 10. That's 256. So the sum of all of it gave us 256. Give me a second. All right, after we do that now, what we're gonna then do is use the formula that tells us that the standard deviation is the square root of the sum of fx squared minus the sum of f times x all square divided by n over n. As I said, Jamie, sometimes you see n minus 1, that's if n is very large. The only time you're going to see n minus 1 is if n is very large. So if you research it, you see n minus 1, all right? And n minus 1 is only used for large data set. So for Inte math, always divide by n, all right?
Yes, sir.
All right, so now when we do that now, we're just gonna replace it now with the numbers that we have. The numbers that we have was the sum of fx squared. The sum of that was 2201.5, 2201.5, minus now the sum of fx all square. Now look at this, the sum of fx is 256, so that is 256 squared, but then you divide it by n, and n was 30, I believe, and then we divide it by 30. All right, so We're going to simplify first before we do anything. So this is just 2201.5 minus 256 squared is 65,536 over 30 divided by 30. Now, when you divide that number, that big number by 30, you get 2184 something. So 2201.5 minus this division part, this part that we divide works out to be 2184.3. All of that is then divided by 30. So now we can put that in the calculator. Standard deviation is the square root of, the numerator would simplify to be 2201.5 minus 2184.3. That's 17.3 divided by 30. 17.3 divided by 30 is 0.57. So it's a square root of 0.57. And the square root of 0.57 is 0.76. So notice how small the standard deviation is, Jamie. 0.76. So that means on average, each person's foot size does differ from the mean by 0.76. I'll work out the standard deviation without even finding the mean. Notice this way we don't find the mean. We didn't find the mean, don't it?
Also,
Yeah, if we wanted the mean though, remember that for group data, the mean is bar x is equal to the sum of fx over n. So in this case, if we wanted to find the mean would just be 256 over 30. And 256 over 30 is 8.5. 8.5. All right, so that means on average, the 7 differ by 1.5, 7.5 differ by 1, 8 differ by a half, 8.5 differ by nothing. But in general, on average, each person's shoe size differ by 0.76, less than 1, which is very good. For shoe size, standard deviation generally very small, which is good. All right, so that would be bar X. Now, Jamie, as I said, please, if you get a group data question like this, I want you to just remember these formulas instead of doing this, right? I'm not gonna do the standard deviation and show you get the exact same answer, but I'm just gonna do the mean. Some persons literally do this, Jamie. Go from the data set, write the 7 twice, write the 7.5 3 times, and they write out the 8 5 times. And if you just do that, if you do that and write out all of them and then add it up and divide by 30, you're still going to get the 8.5. Because don't they save time to just multiply them f times x 14 instead of say 7 plus 7 to get the 14. Then add 7.5 3 times. Isn't it easier to just say f times x then divide it by n?
yes, sir.
Yeah, and it's way easier to also remember this formula instead of always going to raw data. All right, so Jamie, please, when you get a table question, don't ever be listing out the whole thing and then work it out just because you want to remember one formula. Remember them both. So if it is raw data, you use the raw data formula. If it's group data, you use the group data formula, right?
Yes, sir.
All right, cool. So now that I give you that, I'm going to give you a group data question to attempt. So was a group data question in the worksheet? Let me see. Well, partially, that part partially. All right. Oh, yes, here's a group data question. All right, Jamie, so this one is yours. Part A, I want you to do part A, part B, part C, and part D. I'm really interested in your part D to see how you comment on it. You're going to do a full question here. This could be a full question on an exam. Maybe a question 3. So the question 1, you're going to do that question here. Oh, you're putting down the table. Okay. Let me copy the question so you not have to coming back so much. Calculate in. All right, so I copied the question there. So you can work out the mean and the standard deviation. 8 marks. So it's 3 marks for the mean and 8 marks for the standard deviation.
Number of workers. Those supposed to be students or
Oh yeah, workers, sorry. That should have said students, yeah. Typo error there. Yeah. A random sample of students on mobile phones. So that's one of the biggest disadvantage with questionnaire. So for example, you notice from this questionnaire that I gathered, 32 students said they only use the phone for an hour a day. And we know that's a lie, right?
yes, sir.
All right. So that's one of the big disadvantage with questionnaire. People don't have to be honest. Thirty-two square, 60 square times 32. Yeah, that's correct. All right, all is correct. It's 12 and a half. Yeah, 12 and a half. Yeah, speculated. All right, so you're going to 8 marks now. Compute the median. Let me see how you're going to find the median in a group data.
Can't remember if it's n minus
N
one.
plus 1, plus 1, plus 1. Yes. Half n plus 1 term. Very good. So the 35th term. Let me see how you're going to find the 35th term.
I think you have to make the intervals.
So look at it. The first 6 is 30. Next 10 is 40. 10 plus 6 is what?
16.
16. So if you add 18 more, that's what?
34.
So the 35th term would be in starting at good 32. So which number is that? What's the median then? 60. Good, good. Yeah. Would fall in that group. Good. And would you believe me again if I told you that I have boys that would list out all 69 of them and then circle the 35th?
No.
Yes, that's crazy. You have persons that are that serious
Oh.
just because they don't want to remember that formula. So I'm
Well,
glad that you remember it. I have the
the
n plus 1
most
term.
frequent, so may just be 32.
Repeat?
Mode is the most frequent,
Yes,
so
the most frequent. Yeah. So the most frequent is what?
it's 60 minutes because it's
60.
32.
Yes, 60. Yeah. All right. Interquartile range now.
No, you need to make intervals for, but I don't remember of
For,
what.
for interquart, remember the upper quartile, it's 3/4 the n plus 1 term. And the lower quartile is 1/4 the n plus 1 term. So the 50-second number is 50 seconds time in minutes. It's 17.5 term.
Would be in this class.
Yeah, so the 17th is in the 34. So that corresponds to, yeah, 50. So the lower quartile is 50 and the upper quartile is
Upper quartile is 50.
the upper quartile is how much?
Wouldn't it be in the same class, the 50?
34
52.
to, let me say 34. No, it wouldn't be in the 50 range. From the 35th coming to the 66th term, that's a 60. Isn't that so? Remember, this is saying if you were to list them out, the first 6 is 30. Then from the 7th number to the 16th number, that's 40, right?
So repeat that?
I'm saying if you were to list out the numbers, it's saying that the first 6, the frequency, the first 6 is 30. Then from the 7th to the 16th number is 40. If you were to list them out, right?
Yes, sir.
And then from the 17.5th up to the 34th number, that's 50. So that's how you get the
Oh,
lower
yes.
quartile.
Yeah, I
So
see
the
what
upper
you're saying.
quartile one falls where?
From it's in the 60.
60, very good, 60.
Yeah.
All right. 10, very good. Minutes. I love that you put the minutes. Good. So now comment on the distribution. Comment on the time spent on phone. Now, let me give you a hint. Anytime they ask you to comment, what they're asking you to do is give an overview of the measure of spread and the measure of central tendency. So notice that the median you got was 60 and the mode was also 60 and the mean was 53. So you can comment generally, the average time spent on phones was in between 50 to 60 minutes. And then you can give them a general overview on the measure of spread, which is like the standard deviation or your interquartile range. All right. So that's why when they say briefly, briefly mean don't touch on everything, summarize it. And summarizing it is presenting all 3 data points. For the measure of spread, mean, mode, median. Notice that the mean, mode, and median all lie between 50 to 60, right?
Yes, sir.
So we can generalize and say on average, students spend between 50 to 60 minutes on their phone. And then now we can use our standard deviation and interquartile range to discuss the measure of spread. So that's interpreting your results, which is key.
So you still want me to do the question?
No, you don't have to write it down as long as you're good with what you'd say now, right?
Yeah, I understand.
Okay. All right. Now, Jamie, the next thing I want you to do, I'm just going to share my screen for a split second. Sometimes they don't necessarily give you the group data, but they can give you a question like this. So the last one that you were doing with the box plot, like sometime they give you something like this. They give you the sum of x squared and the sum of this square. They ask you to find the standard deviation. Now, Jamie, when they don't give you the frequency, I'm just going to write down the formula here. When they don't give you the frequency, the standard deviation is the same formula, standard deviation. When they don't give you frequency, so you have absolutely no frequency to work with, it would just be the sum of xi squared minus the sum of xi all square divided by n all over n. Only difference is that we take out the frequency because we don't know what the frequency is, right? But we know it's group data, right, Jamie?
Yes, sir.
So sometimes what I'm showing you is that this question now, they didn't give you any frequency, how much person get what score, because it was a follow-up from the box plot. So what I want you to do is work out the standard deviation for Brian and Lewis score. You have the data already for Brian and Lewis, but now I want you to just take down what they give. It says, given that the sum of all Lewis scores is 1,029 and the sum of all Brian scores is 1,111. Then they say the sum of Brian's score when you square it is this. The sum of Lewis' score when you square it is this. Find the standard deviation. So go ahead and find the standard deviation for me when they give it like this. And then comment and tell me which one performed better in ADMAS.
So I'm finding the standard deviation.
Yes, find the standard deviation for Brian and Lewis.
Okay. We need an n.
Yeah, but you had n already. Remember, you had started the question from way back around here. Read back the question. Remember, they said that they both had 15 assignments to complete.
Okay.
Yeah. Square root of 21 is what? 4.6. Yep. All right, wonderful. Very good, Jamie. Very good. So notice Lewis is what? Lower standard deviation mean? Lewis is
More consistent.
more consistent. Very good. So even though they have close to the same median and probably close to the same mean, we realize that Lewis is just more consistent than Brian. So yeah, Lewis is the better student.
Yes, sir.
All right. Now, as I said, now that that wraps up for today, I am going to show you how you can put in Excel, how you can create your box plot. So whenever you type in your data set, right, however, you can label it up as well. But I just put in the raw data to show you. Copy it. You're gonna go to insert. Are you seeing my screen?
Yes, sir.
All right, so you copy and you go to insert. Let me highlight it again. You go to insert. When you go to insert, you're looking for insert statistics chart. So that's gonna pop up. That's the insert statistics chart. You're gonna click on not histogram, not Pareto, but here, box plot. All right, we're gonna look at scatter plot soon, but for now, we'll go over to line graph. We're looking at just the box plot. This is the box plot. You can then, narrate along a little bit. You can play around with it. You can change the color. You can widen it. You can do whatever you want with it. All right, this is where you put on the chart title. And then, of course, you can add your scale on the diagram. But I just showed you where you find the box plot. So you find it in, remember you find it right here where it says insert statistical, insert statistics chart. So you always look for the one that's an insert statistic chart. All right, Jamie?
All right, sir.
Now, whenever you're making the stem and leaf, you can just make that normally in Microsoft. So you just type it up normally and copy it to the Word document. All right?
All right.
Yeah. So remember now, what I want you to do is, let me go back to your wonderful start to your IA. All right? I want you to, as you have your IA here, I want you to work out the ratios for me now. And then as you work out the ratios, I want you to work out, you're working out a lot of stuff for me for next week. You work out the ratios, then you're gonna draw your stem and leaf. All right, so remember your key is important. So maybe in this case, you want to have like, notice most of them probably gonna be between 0.9 to 1.5. I don't think any will be over 1.5. So maybe you want to work with a stem like 0, 9. Tell them 0/9 means 0.9, right?
Oh, sir, mine is number
Repeat.
27. Mine is number 27.
27. Oh, this is your measurement?
Yeah.
Oh, that's your measurement. Oh, 184 centimeter. Whoa, you're over 6 feet.
A little bit.
Yeah, comfortably. You're 6'1".
Oh, not yet.
Not yet. All right. I'm 183, so you're pretty tall, man. That's good. That's good. That's good. I need to measure my span as well. I doubt my span is that large though. All right, excellent. All right. So Jamie, trust me, you go to university, everyone going to love you. You're very tall, well-groomed, well-behaved. All right. You have a nice foundation working with. I just really want for intimate place as well. Right? We're putting in the work so we can place the right.
Sir.
Yeah. So as I said, now work out all the ratios, and I want you to do the stem and leaf. I want you to do the box plot. I want you to also work out now the measures of central tendency to show what is the average ratio. you get. Hopefully it's close to being 1, right? Close to say it is 1 to 1. We want to get that 1 ratio. So work out the average, work out the mode, work out the median, work out the stem and leaf, the box plot. Then you're going to work out your measures of spread. So I want you to work out the range, interquartile range, standard deviation. You don't need variance. Those 3, want you to work out those. All right. We're not going to start describing them yet because we're going to do an overall, this when we get to discussion where we discuss everything. We're going to discuss everything when we get to, let me go back here. When we finish next week, we're going to be talking about, not next week, tomorrow we're going to be looking at, no, tomorrow is not our next statistics class. When we start talking about symmetry, positively skewed, negatively skewed, even though we have an idea of it, scatter plots. After we finish all our diagrams to present the data, we're going to talk about them later on in our discussion. So now it's just focusing on the calculation. Bar and pi, those who come along the way. Don't we'll use histogram. Don't see how, I'll think of how we can use it because the more diagrams you have, the more you make your stuff presentable, right? You want to show that you're fully describing because remember, descriptive statistics is using summary data. You're presenting your summary data, right? You want your teacher say, whoa, Jamie go hard, man, right?
Sir, do
Yeah.
the graphs count towards your word count?
Huh?
Do the charts
No,
count?
no. Those
Alright.
aren't in the word count. So you don't have to worry about your word limit. All right. So I just want you to do all of these that we've done now, the box plot, stem and leaf, and also do all your measures of spread and central tendency. All right.
Alright.
All right. So tomorrow, remember, we're going to be going back to here. We finish sequence and series. So now we're going to be starting matrices tomorrow. All right. All right. So take care, Jamie. See you tomorrow.